All right, Algebra 2. Welcome, guys. We are doing our first little video here. So just like we talked about in the Zoom, I'm going to put up this video onto the YouTube channel and just kind of walk you guys through some of the basics of factoring. I know that this is not the first time you've done it, but maybe it's been quite a while since you've done it. So pay close attention. This is pretty much how all the videos are going to be looking here. We're going to write the notes up. Some of the notes will be already pre-written. Most of the example problems will be already pre-written. We will have not worked them out yet. That's kind of the point of me doing the video, to guide you through the example problems. You can pause the video, rewind the video, all that stuff. So do that. Use these videos to your advantage. And step one, at least, is you guys are watching the videos. All right. We're going to have a little assignment that goes along with it. Do it over the weekend. Turn it in by Monday. We'll get it graded and just get some basic feedback to you. Okay. All right. So let's jump into it. Introduction assignment. You're going to need to go to page S67, just like we did in the Zoom. We're talking about factoring. Okay. So right here, we are going to jump into our first problem. All right. Little quick review. This is a polynomial. All right. X squared minus 5x minus 14. And polynomial is a bit of a generic term. It basically just means many terms, okay? And the specific type of polynomial, it is a trinomial. And what does trinomial mean? It means 3 terms. All right, so that's that little breakdown right there for you. All right, so we need to factor it. Let's do our work here in a different color. So we're going to go with blue. Okay, step 1 is put your parentheses out there. All right. We will be breaking this trinomial down into 2 sets of parentheses. And these little parentheses, they are called binomials. Bi meaning 2, so 2 terms. All right. One thing that we should notice is this last sign right here is a negative. When that sign is a negative, that means in the parentheses, we will have opposite signs, positive and negative. And here's why. Because when you multiply a positive and a negative, you create a negative. That's how that second sign gets created. Okay. Now, the next step we need is this 14. We need to break that down into all the possible factors that could create 14. All right. So 1 and 14 could make 14. That's 1 times 14. Or 2 and 7 could make 14. Now, the next step, is it possible to create this middle guy? Is it possible to create 5 with 1 and 14 and 2 and 7, and now you get to use addition or subtraction? The answer is yes, you can with these guys right here, 2 and 7. So if we manipulate 2 and 7, that can create 5. And it's not just any 5. What kind of 5 is it? It's a negative 5. That's this sign right here. Can we create negative 5 with the numbers 2 and 7? Yes, we can. If we put the 7 right here in front of a negative, and if we put the 2 right here in front of the positive, that will create negative 5. All right, positive 2 minus 7 creates negative 5. Now, what goes here in this first part is x and another x. And why is that? Because right there we have x squared. That means you have 2 x's, and you need to break them down into individual parts. So 2 x's, break it down. There's an x right here. There's an x right here. All right, so that's our answer. X plus 2 in parentheses and x minus 7 in parentheses. That is our answer to the first example. All right, let's move into example 2. What we're looking at here is, as the note says, it's a perfect square binomial. So it is a binomial. That means you have 2 terms, but it's perfect square. And what does that mean? Let's finish out the definition. Both terms are perfect squares. And if we don't know what a perfect square is, that really means that you could take the square root of a number and it works out perfectly. So x squared if we were to take the square root of x squared, what does that equal? X. And if we were to take the square root of 81, what does that equal? 9. So both work out perfectly, therefore fitting the parameters of being a perfect square binomial. Okay, it's going to need the double parentheses, just like normal factoring. You see that it has that negative sign, just like we talked about in the trinomial. So that means in here, we're going to have opposite signs. Okay, and what does the x squared break down into? X and x. And what does 81 break down into? Perfectly, 9 and 9. And there we go. It works out perfectly. Now, how do you check your work? Let's say you're wondering, okay, I get that, but I don't know if that's actually right. Okay, so in other words, how do you go backwards and check your work? Which, if I'm being honest, as a math teacher, it's kind of a lost start, right? Not many students check their work. This is how you would do it, though. You would use what's called FOIL. All right, FOIL is an acronym. It stands for first, outer, inner, last. We would just go backwards. What is x times x? It's x squared. All right, we have that. What is 9 times x? It's 9x. Then, what is x times negative 9? That's a negative 9x. Now, why do we want that? 9x minus 9x is 0. We want that because do you see a 9x in the original problem? No, you don't. All right, so there's that. But the last step here, what is 9 times negative 9? That would be a negative 81. And we do see that in the original problem. All right, so all of that being said is that your actual answer is this part right here, x plus 9, x minus 9. All right. Let's move into example 3. I believe we only have 4 examples, so 2 more to go, guys. Okay, first step for example 3, as the note says, find a common factor in each term. So what we're looking at is 3x squared minus 147. Sorry. Do we have a common factor? And what is a common factor? That would either be a number that they both share, or a variable that they both share. Well, I only see an x on one term, so it can't be the variable. So it must be a number. So can 3 go into itself? Yes, one time. Can 3 go into 147? I'm thinking so. How many times? 49 times. So that means let's factor out the 3. So take the 3 out, and let's rewrite what we have left over. We have x squared minus 49. Are we done? No. If you look really close, x squared minus 49, there's something special about it. And what is that special thing? It's this right here. It's a perfect square binomial. Now, how do we know that? Because x squared is a perfect square, and 49 is a perfect square. What times what make 49? 7. Also, there's that minus sign in between. You have to have a minus sign in between a perfect square binomial. That was something I forgot to mention in the prior problem. You have to have a minus sign for all of this to work for the next step. So what's that next step? Let's break it down. Double sets of parentheses, keep the 3 on the outside. That does not just disappear. X squared becomes x and x. What goes in here? Plus and minus. And what does 49 break down into? 7 and 7. All right, that is the answer to example 3. All right, let's move on. We're looking at our final example right here. Look at each term. There must be a common factor. What is that common factor? 10, 55, and 200. What would they share? They all share a 5. So let's take that 5 out. And when I say take the 5 out, I basically mean 10 divided by 5. What is it? 55 divided by 5. What is it? And 200 divided by 5. What is it? Okay. So we have 2x squared. 10 divided by 5 is 2. The x squared drops down. Minus, what's 55 divided by 5? 11. The x is still there. Minus, and what's 200 divided by 5? That's going to be 40. That's there. And unfortunately, we're not done. All right, what we did create is a trinomial, and this trinomial can be factored. So the 5 does not just disappear. Keep it right there, but we're going to break it down one more time. Double set of parentheses. Okay, again, I see a minus sign right here, which means in this parenthesis, I'm going to have a positive, and in the other, I'm going to have a negative. Okay, now the x squared right here still breaks down into x and x. Now, what we haven't used quite yet is a coefficient. That is a number in front of a variable. So that 2 has to break down, and a 2 is a prime number, so it can only be 1 and 2. Let's put that 2 right here. Let's put the 1 right here. And by the way, you don't have to put a 1, but I'm just showing you just to be very thorough with that. All right, and then 40. What does 40 break down into? All right, 40 could be 4 and 10. Let's see, it could be, what, 8 and 5. Okay, and let's see, I mean, it could be 20 and 2. All right, so which one of these options will work for us? All right, and here's how you check it. What I use, I call it the double chin, double check. All right, kind of looks like a double chin there. So you got a double chin, double check, and we have to put our options in to see if it works. Now, how do you know where to start? All right, don't just go guessing at it. There is a logical way to start, and the best way to start is pick the pair that is already closest together. So you have 4 and 10. How far apart are they? 6. You have 8 and 5. How far apart are they? 3. Clearly, the 8 and 5 are the closest. So let's start with the 8 and 5. Now, where do we put it? Do we put the 8 first? Do we put the 5 first? That could be up to you. All right. The more of these problems that you do, you're going to start to use a little bit more logic with it. Okay. In the middle, you see how we're trying to create an 11. That's the magic that we're trying to create here. So I'm going to put the 5 here and the 8 right here. Now let's check our work. Is it in the right spot? The 5 connects to the 1x, right? 5 connects to the 1x. What is 5 times 1x? It is 5x. You'll see how the 2x connects over here to a negative 8. Make sure you see that. There's a negative sign in front of the 8. So 2x and a negative 8 make a negative 16x. What is 5x minus 16x? A little bit of magic. It is negative 11x. And that is what we needed. Negative 11x is our middle term. So this right here is the final answer for the original trinomial that was given. All right, guys, that covers it. Your first official day of intro notes. Going to do some example problems here for you, and hopefully you guys are able to accomplish the homework. All right, we'll see you guys later.